Hello, everyone. My name is Corbin Gustafson, and I'm going to be talking about the producer-consumer architecture in LabVIEW. So I've made a couple of videos before this that went over producer-consumer for data collection modules, right? So you might have a DAC loop and a logging loop, but now I'm going to go over the event handler loop and the message handler loop with just a basic overview on how it works, how you could use it, and just like a quick run through basically. Okay, let's get started. So here we are on a blank VI, and I'm just gonna go and make two while loops. This top one right here, we're gonna call the event handler loop. And this bottom one is the message handler loop. We're going to connect these two loops with the queue, and the way that you get a queue is you go into your synchronization tab, queue operations, and we're just going to put this up here, and we're going to have an obtain queue element, an in queue on the event handler side, and a dequeue element on the message handler side. Basically, what this means is that our event handler is our producer, and our message handler is the consumer. And then you're going to wire those up. Once you have those wired up, you're going to actually want to be able to in-queue messages somehow. And for the architecture that I'm most familiar with building, the event handler loop is going to handle events based on user interfaces with the front screen. So how that looks inside of this loop is you're going to want a structure that's an event structure right here that's going to allow you to interact with front page based clicks. So the scenario that we're going to set up here today is we have a system that needs to initialize hardware, and then we want to be able to turn a relay on and off. And then we also want to shut down. So that's a pretty basic use case of this producer consumer architecture, but it's a standard one that you might have to use again and again and again, right? So how do we actually do this, right? So to initialize hardware, how I think about that in my mind is on the run of the VI, begin like to allocate those resources for those channels that that hardware may be on. And so how do I do that? Within the timeout loop, we're going to add a case structure. And that case structure, also, the timeout loop will run however long or however many milliseconds you put into this event timeout block. So if you want your timeout loop to run every 50 milliseconds, you're going to want to put a 50 right here. So the first time this loop runs, which will be within 50 milliseconds after the VI is started. And also we need a first call block right here. So the first time that this loop runs, this first call block will output a true Boolean into this case structure. So that means that we want to in-queue an element that tells the message handler to initialize hardware when this block is true. So we need to actually drag this in here. So we need to put some sort of message in here that will be fed into this message handler's loops case structure. And inside of that case structure, we can initialize that hardware. So how do we do that? We're gonna need to make an enum data type. To make an enum data type, you're gonna want to go into your project folder, go to File, New, Type Definition. Inside of this type definition, you can right-click, go to Ring and Enum, and we're just gonna place an enum right here. This enum I'll call the EHL MHL enum. So we have three cases. We have initialize hardware, turn relay on and off, and shut down, which means that this enum needs to reflect that. So if we go to edit items, inside of this we can put init HW, we can put relay toggle, and we can put shut down. Now we have three cases that we can feed from our EHL into our MHL. Go ahead and save that, and I like to save that as EHL underscore MHL. Now that you're back here on your main VI, go ahead and take your EHL MHL control and drag it onto your front screen. You're also going to want to drag another EHL MHL control out to put into your element data type of your obtain queue block. Now when you have your, when that queue is put into your obtain element block and into your in queue element block, you can change this to initialize hardware. And now what's happening here is when this block is true, so when timeout is ran for the very first time, it will in queue this element one time, initialize hardware. That element will be dequeued by this message handler loop and fed into this case structure. If we go to add case for every value, we have an initialized hardware case. Now inside of this message handler loop in our initiate hardware case, we're going to need to set up some sort of digital output inside of DACMX so that we can actually interact with that digital output pin, from the hardware side. So how do we do that? Let's go into measurement.io or measurement.io, ini DACMX, go ahead and pin that. And we're going to need to create a channel here. This channel is going to be a digital output channel. So that means that you have a line that you need to control. You could have this as a constant or a control. Let's have it as a control right here. We can call this control relay 1. This one's important too. Line grouping. Go ahead and create a constant there. If you need to control lots of relays with just this one signal, then you're going to have one channel for all lines. But if you have a lot of individual relays that you're controlling, one channel for each line. So now we need to, we can write this to low. Go ahead and change it to digital, single channel, single sample, Boolean. You want this to start in its low state, so false. And then you can go ahead and auto start this channel. But now we want to be able to store this this task between loops in our message handler. And so how do we go about doing that? An in-place event structure. So if you right click on the side of this in-place event structure and go to add unbundle bundle elements, you'll see that you have these blocks pop up. They have the input is a cluster, and this basically just acts as a unbundle rebundle case structure. So we need to be able to input some sort of input structure that allows us to put in the task and the error from our DACMX digital output system right here. So how do we do that? You're once again going to want to go to your project file right here. Go to new and create another type def. Inside of this type def, we're going to want to put a cluster data type. You can call this one DO data or DO cluster. If you had multiple different types of things, then you might want to call this something different, but for this project, we'll call this DO cluster. Inside of this cluster, we're going to want to put a DACMX task. So if you right click, go to IO, DACMX name controls, task, and then we're also going to want to go to data containers and then error out 3D. So you can call this the DO task, and you can call this one the DO error. Go ahead and save that, exit, and let's put that right into our project. If you right click on the, or if you double click on the side of this, you get this box. Now we're going to take this empty cluster and put it into the input of this in place event structure. If you right click on that, DO task, drag it down, DO error, and wire in task out and error out in there, we can place all of this inside of a shift register. Go ahead, Andrew. There we go. I cleaned up the wires a little bit, and now we have the ability to interact with whatever we need to interact with. So next thing, let's have a button on the front page that allows us to actually interact with this hardware. So right click, button, push button. Let's call this button relay toggle. So now what we want to do is we want to create a system where when this button is pressed down, it will write a high signal to that digital output line. And if this signal is turned off, then it'll write a low signal to that digital output line. As you can see, we have our button right here. I'm just going to drag it off to the side, and I'm going to create an event case for when this button is clicked. So we go to right click on this little block up here, add event case, relay one toggle, that's the name of our button, and value change. So whenever this relay button is toggled, we want to enqueue an event or enqueue an element, an enum, and that will get handled by our message handler loop. So go ahead and add an enqueue element block. And then if you right click on this element, create a constant, relay toggle. So now we're enqueuing the element relay toggle to be dequeued by our message handler loop. So if we go into relay toggle, now whenever this button is pressed, that's a value change on that button, and relay toggle will be enqueued. So what we want to do is, because of that, we want to check the value of this button and then write it to the task that's stored inside of this shift register. So how do we do that? Let's go into in place event structure and place one down right here. Let's unbundle and bundle elements. Now we have this DO task. Let's also take out the DO error. Whenever this relay button is toggled, we want to go into our NI DACMX and we want to write whatever value it sees. So digital, single channel, single sample Boolean. Connect those wires up. Make sure it's on auto start. And then let's create a reference to this button. Right click, go to create, property node, value. And let's wire that value straight into that data type right there. What this does is, so every time that this loop is ran in the case of relay toggle, the computer will check the value of this button over here, and then it will write it to this data block right here. So now we have that set up right there. You're also going to want to go ahead and put your output cluster into this white block right here. And as you can see, we still have some case where this button, or where this line is not connected all the way across. So what is that last thing that we need to worry about? It's the shutdown case. So we need a button that allows the user to shut down. So if we right click on here and create a control, it will give us that stop button. But we don't want that stop button in here. We want that stop button right here. We want to add a case for that stop. So now we have this stop case, and just like before, we want to create a an event based on that button. So when that button value is changed, we want to enqueue a shutdown element into our system. There we go, shutdown. And that will be dequeued by this block right here. Let's just go ahead and put a unbundle by name right here. You'll see why in a second. Once you have that, you're going to want to go into your NI DACMX, grab a stop and a clear. Also go ahead and grab a bundle by name. And go into your project file and drag in a DO cluster control. You're going to want to connect that DO cluster control to the top of the input cluster and just get the error out. You're going to want to connect that error to your error out from your clear task, and then connect those blocks as you normally would. And then you're also going to want to put a true constant inside of here and feed that into your stop condition loop right here. And then in all the other blocks, go ahead and use a false constant. So now also on this stop line, you're going to want to have a true and a false everywhere else. Now if you look in the top left, we have a unbroken arrow, which means that everything is able to run properly. So if you had some sort of device hooked up to your DAC system, then you would be able to stop it properly. Thank you so much for watching. This was an intro into the producer-consumer event handler message handler loop architecture, and I'll see you in the next one. Thank you. Goodbye.